In this lecture, we will discuss a few more things about classes and objects.
We're going to start by actually reviewing a little bit about object-oriented programming. So I think we've said this several times, but it's worth mentioning again that Visual Basic is an object-oriented programming language, or OOP. I'm probably just going to say object-oriented language. And if you remember, an object-oriented language just simply identifies the components of the program that we can classify into classes and objects. In fact, every single entity in our programming language is encapsulated in these different classes and objects. So what are classes? Well, a class is a structure. It's actually very similar to the structures we talked about before, but it lets us define the data or the attributes and the operations of a single entity. In other words, we're identifying the main properties of a particular entity and the operations that we can perform on that particular entity. Now, the attributes of our entity would be represented using variables. So we can declare all these different variables, and these variables would correspond to the different properties or attributes of that particular entity. And then the operations that we can perform on the entity would be represented as subprocedures. All right, so what are objects? Well, an object would be a single instance of a class. So the idea with this is we would have this class that would define all of the different features and attributes and methods or subprocedures for an entity, and then we can create objects of that class. Now, this process of creating an object is what we call instantiation. So what we're really doing here is the class defines everything. The object will allocate memory to store a single instance of that particular class. And each object would have its own set of data and operations. So really what we're doing is we can have as many objects as we want, and each one has its own copy of the variables and the methods that it can call. So just to give an example, if we create two objects of the same class, well, the names of all the members will be the same, but the data can be different. The data that's actually stored can be different among those different objects. So we think of each object of a class as its own independent instance of that particular class. And what I store in that particular object has no say in what's stored in any other object of that class. Let's look at a simple example just to help show you how we can identify the different attributes and operations. Let's say we wanted to create a class that defines a clock. Now, if you've taken CS 121, you should be familiar with this because we went over this as a big example when we talked about objects and classes. But let's just think about what are some of the attributes and operations we can have for a clock. Let's start with the attributes. So what data would we need to store about a particular clock? Well, if we're talking about the time, we probably need to know something about the hour. So we need to know what hour the time is. We should also know what the minute of the current time is. And then we should also know the second of the current time. So these would be different attributes for a particular clock. You should know the hour, minute, and second. Now we can add some more stuff in here depending on the type of clock you have. You could store whether it's AM or PM. You could store the day of the week. There's all sorts of stuff, but we'll just say hour, minute, and second for now to keep it simple. Now what about the operations that we can have, or the sub-procedures? Well, think about some of the operations that you can do with a normal clock. One thing is to set the time. You can set the time on a particular watch or an alarm clock. So we should have an operation that allows us to set the hour, minute, and second. We should also be able to get the current time. So anytime you look at your watch or check your phone for the clock, you should be able to get the current time whenever you want. And then since the time changes, we need to be able to increment the values of all these different variables. So we should be able to increment the hour. Usually we'll just do it by 1, and then we would have to include some cases whenever we go past 12 if you're doing a 12-hour format, or 24 when you do a 24-hour format. We should also have a procedure for handling incrementing the minute. So when the minute changes, you should be able to increment it, and then we have to handle the case when the minute gets to 60. And then we should also be able to increment the second um, every single second. So whenever it gets to 60, then we have to do some stuff to change the minute and the second. But there could be more operations that we can have in here, but these are some of the more basic ones that we would have in a clock class. So how do we use objects in classes in Visual Basic? Well, you may or may not know this already, but objects such as buttons, text boxes, labels, and even other non-visual objects are actually created from a class. Just think about it for a minute. Whenever you create a button, for instance, that particular object would have attributes or characteristics that describes the objects. So you have like event properties, name properties, size properties. You have all these different properties. These properties would be the attributes of like a button class, for example. And then they also have methods and events that would describe how they behave. So we would have a method for a button that describes what happens when you click on that particular button. And all these attributes and methods would be provided in the class. So all these different tools that we've been using, there is actually a class defined that describes all of the attributes and operations for that particular tool. And then every single time we create a tool, we're creating an object of the class. We're creating an instance of that class. So we can have however many buttons we want, but each one is independent of each other, but they all still have the same properties and they still have the same operations that can be performed on that. Same thing goes for text boxes or labels or picture boxes or any other tools that we include. So all these different objects that we're adding to our forms are objects of pre-made classes in Visual Basic. Here is the syntax for any class in Visual Basic. So we start with public class and then the name of the class. Now we could make the class private, but that doesn't do us much good. That means that no other class can access anything in this class. So we usually make it public. Inside, we would then include all the attributes and the methods for that class. So I just put comments here as placeholders to say we would have attributes and methods, but we would have different variable declarations for all the attributes we would have. We would have all the sub-procedures that we wanted for this particular class. And then we would just end it with end class. So it just kind of follows the trend that we'd have public class, the name, some stuff inside the body of the class, and then we always end it with end, and then of course this is going to end with class. In order to create an object, the first thing we have to do is declare an object. And the syntax for this is just like declaring a variable. So if you remember how to declare variables, which you should at this point, then you already know how to declare an object. The only difference is the data type that we're going to use in our declaration statement is going to be the name of the class instead of some given data type like an integer or a double. So let me give you the format for this. So we're still going to have dim, and then my object is just a placeholder. It's going to be whatever object variable you want, and then we still have the word as, and then we have the name of the class. So we're just going to have dim, the name of the object, as, and then the name of the class, and that just simply declares the object. Now, declaring the object is not enough. All we've done is just create a variable basically, but there's nothing in here. We still need to instantiate the object, and this is where we would allocate memory to store a copy of all of the attributes of a particular class, and then be able to call the sub-procedures of that class. So the way we do this is that we would call a special class method, and this method is just going to be the name of the class, and this will store the result in the object. So calling this method will take care of creating the memory for us, and then a reference to that memory will be stored in our object, so then we can refer to it anytime we need to use that particular object. This method is what we call a constructor. The reason why it's called a constructor is because it constructs the space needed for the object of the class. See what they did there? In order to use this constructor properly though, we also have to include the word new in front of our constructor. So the way we would do this is we would have our object, and then we would set it equal to new, the name of the class, and then parentheses. So this class name with the parentheses down here is our constructor, but we have to include the word new in front of it. So this is going to create a new instance of this particular class. Now, I will mention that we can declare and instantiate an object on the same line. We've shown that we can do it on separate lines. One line would declare the object, another line would instantiate the object, but if you wanted to, you can combine them into a single line. And this is just identical to how we would declare and initialize variables on the same line. So just to give an example here, we have dim my object as class name equals new class name. So we're still declaring our object, and we're saying the type of it is going to be whatever our class is. It's just on the same line we say equals new and then call the constructor of that class. In fact, this is usually what most people do, where they just create the object and then instantiate it on the same line. If you want to do it in separate lines, that's perfectly fine. There's nothing wrong with it. Either approach is okay. I just think more people are used to using this approach for declaring instantiating rather than doing it on separate lines.